today. I don't know. Okay, so this is going back to theory discussion. I'm done with the problem solving, right? We go to the derivation of the Heisenberg theory of uncertainty. Okay, so uncertainty meaning that there is no exact positioning and there's no exact momentum as the light particle or the electrons travels, okay, from point A to point B or any reference during the motion, the movement of those particles being considered, which is specifically atomic particles. Okay, something like that. But what we understand really, guys, really that does these particles. We mean the particles. It could be electrons, protons, neutrons, positrons, baryons, bosons, leptons, quarks, like that. Positron, photon, a lot. Okay. So when you mean about that, this is studying in a microscopic scale, meaning micro, okay, micromolecules we cannot see in our naked eye. That's why it needs experimental evidence to back up for better understanding of this particular topic. Okay, and this is also related to the rays, beta ray, gamma ray, alpha ray. The gamma ray is specifically the X-rays, okay, in our chest X-ray. So that is the, one type of emission of radiation. Okay, so actually there's a lot. There's also infrared radiation, ultraviolet radiation, and in fact, the Proxima Centauri, the Proxima Centauri is the scientific name of the sun. Okay, and according to my research, a long time ago when I was in high school, the Proxima Centauri, which is the sun, is the biggest star in the universe. Okay, so basically the sun is also a star, but in a macroscopic scale, very, very, very big star. Okay, so he or she is the biggest among the stars in the galaxy or in the Milky Way. Okay, so in the planetary sense, we talk about galaxy, Milky Way, universe, the planets, the comets, the asteroids, something like that. Then we know also the gravitational force there because there are a lot of orbits that these planets followed during the revolution and rotation of each orbit. Okay, something like that. But it's very, very clear to us that the Earth revolves around the Sun 1 year, 365 days, something like that. Okay, and this Earth has its own spin, spin, spin. So this is called quantum spin or planet Earth. Okay, just like in the Niels Bohr theory of nucleus of different particles, right? It's gonna be like that also the principle. Okay, going back to the light. The light, as we know, it will travels from high energy to lower energy in a discrete particles and discrete packets called the quanta. Okay, what is quanta, Sir Sotero? Quanta meaning you can produce that particle when the electrons moving from energy level to another level in an excited state. Okay, not excited na ka ng excited. Kung kanta rin na excited state. Meaning jumping to another orbital or to another electron. Okay, especially this photon and electrons are very, friendship with each other. Okay, so they are going to jump from orbital to orbital, something like that. Okay, from high energy to high energy. So at first, that is in a ground state, and then it will be excited or excite state. So it will develop an amount of necessary energy to jump to another energy level to another. But still, the maximum number of electrons must be obeyed, something like that. Okay, you remember that one? Okay, and Hans rule, Mr. Hans. Okay, that any atoms, ions, molecules shall fill first the subshell, meaning orbitals, suborbitals, okay, from highest, like that, available energy, something like that. Okay, okay, you get the point, always from the highest energy to the lowest energy. But in this orbit, guys, so mag-start siya of lower energy, but in the jumping, okay, to another level with higher energy siya. Okay? So 2n squared. Oh, nakinomdom na tana, di ba? Maximum number of electrons is equal to 2n squared, where n stands for the energy level. It could be energy level 1, energy level 2, energy level 3, energy level 4, so on and so forth at infinity, walang kamatayan. Okay, again, Mr. Hans rules state, charot, that the ions and the atoms and the molecules and the nucleus shall fill the subshells, okay, suborbitals in a lower level first, a lower energy level first, and then to the highest available energy. Okay, wala pa man siya mo jump. Okay? Wala pa man siya mo lukso. Okay? So, inkalukso-lukso na nila dito sa laing mga energy level, that's the time, starts talaga siya from, kusog na energy. Okay? So, sa diya pag jump, kung hinay ang energy, matagak na po siya. Okay? So, that's why, starts with higher energy talaga siya. Okay, sa pag-elevate, anong tawag doon? Kanang mukhaan siya ba, mulukso. Jump nga. Kakaloka. Okay? There's another term for that. For the jumping. Ano ba ang tawag doon? Transferring, right? Or shall we say, wala ang term, but more na siya, mag-jump rin siya. Okay? So that's gonna be like that. But the light really class would travel both as a wave and a particle. Okay? Ang particle theory, guys, mo to siyang photoelectric effect ha, ng atong study, but the wave effect of the wave characteristic of the particle, it's more about on the wave functions theory of Mr. Schrodinger, that he analyzed the three-dimensional wave functions, something like that, okay? So, difficult siya because it involves a lot of psi function of x, is equal to the, the integral of negative, infinity to positive infinity, psi function of function, y na naman po, or f, something like that, and cosine dx, cosine x, then dx. So you will do a differential equation for that, okay, and then Laplace transform to obtain the values. And there are a lot of, I think, that's what I've read, there are 10 equations for that. And then before we can come up to the final equation to be used. Okay? So most of the problems of physics also are avoiding that kind of problem, really. Because aside from that, is not very, I don't know, it's not really common or popular. So it looks like it will become negligible to compute for that certain, particle in that way of computing using the Schrodinger equation, really. Okay, because it's very difficult also to discover the probability distribution of an electron that covers certain wavelength, something like that, and we cannot predict. Okay, that's why this Werner Heisenberg develops this theory, because they're trying to avoid this Schrodinger equation because it looks like very complex, very complicated. Okay, and this Mr. Werner Heisenberg in 1947. He discovered the theory of uncertainty principle. Okay, something like that. An electron or any particle should possess uncertainty, something like that. That we could not determine exactly the possession of a certain electrons when it moves as it travels through different paths, something like that. And then if we have determined the exact position, let's say through experimentation, the position will not be also certain. Okay, so it's impossible for the particle to have certain possession and certain momentum at the same time. That's what theory of Heisenberg all about. But Mr. Heisenberg involves the scientific law and formula. Delta x equals to py greater or equal to the Planck constant over 4 pi, something like that. But before that also, this Heisenberg obtained also the theory of Copenhagen theory, Mr. Copenhagen. Marokay sila, oy. So, if they have the discoveries before, they will also carry that after, and then just develop that, and then introduce another theory, but the concept is still coming from the other scientists to other scientists, something like that. So this Heisenberg also get the basic of his theory through Copenhagen theory, as an uncertainty of particle, position, and momentum. But in Copenhagen theory, there's no formula, okay, declared and specified, whereas Mr. Heisenberg developed an experimental evidence, when can we say that the electrons and particles could achieve uncertainty, could either be in position and in momentum. That's only the difference, okay? Scientific law or scientific equation to validate the fact or the scientific theory of this Copenhagen theory. So these are all about still quantum mechanics, okay? It's gonna be like that. Okay, now, as we can remember the dual slit experiment, okay, I will draw here. Charot, wait. What you na to, ko ani pagkuan ay when I took up physics in my college, I don't remember. I extract some of this knowledge. Okay, I just research further and oh my gosh, it's gonna be like this. When I was in college, I didn't have an in-depth, comprehensive knowledge regarding this topic. Okay, really? Yes. It depends naman sa situation because the physics topics and coverage are so wide man sa good siya. So we can also say na we cover that, and okay, something like that. Okay, so going back, so this is dual slit experiment. Ganon. Dual, guys, meaning double. It's just the same, ha? Dual, D-U-A-L, synonymous term for double. Okay, when I say Sotero can sing in a dual voice, meaning I have a female voice, I have also a male voice when I sing songs. Okay, when I built it out high notes, my voice changes from male to female. So meaning to say, I have a dual voices, or dual, D-U-A-L, or I have a double voices. Double meaning two, right? So double or double is just the same in meaning. Okay, so dual slit, okay, experiment, or double slit experiment. Okay, like this. Okay, ganon. The other one is photoelectric effect. I already solved problems for it, right? A while ago. Okay, so photoelectric effect. Oh my gosh. Okay, a combination of the light and electrical energy or electricity. That's why photoelectric, a combination of words. Okay, photoelectric effect. Okay, like this. Okay, moro gini siya magtuyok-tuyok. Ang katong ubang mga kuan naman ang gutok to mga quantum entanglement, quantum superposition, mga ganon. Okay, puno-puno na lamang to siya kung quantum tunneling, mga theory na kayo siya, wala siya mga formulas and equations to let us understand how the wavelength or the wave of the particles, behave. Something like that, okay? So, mura gina siya. Di makita siya nag-involve mga formula good. Okay, ito mga quantum superposition, quantum tunneling, quantum entanglement, mga ganun, di ba? Alam man siya, di ba? In my introductory discussion in touching this for the very, very first time, the quantum mechanics topic of physics and physical chemistry. Okay, like that. So now, kung quantum mechanics gani guys, QM, mo yun yung timan and permi ha, ang experiment nga, dual slit experiment and a photoelectric effect experiment. Okay? Ang photoelectric effect, mo ni gi-prove ang particle theory. Okay, ang dual slit experiment, gi-prove diri ang wave theory, that it contains a wavelength, those particles, as it moves to a certain medium, or whatever, vessels or openings, whatever, okay, like that, they will go there, something like that, and there will be a diffraction of the light emission, something like that, and there will be an interference, and then they will bump there, like that, and there will be an oscillations per second, which is a frequency, and there will be also an intensity for that particular light, and there will also an equivalent kinetic energy. Ganon. Diba? When it goes to the screen, the light, it will reflect the lights also to you. There will be now an interference pattern for that. And that interference pattern, we don't know really exactly what is the probability distribution of the location of each electrons emitted by a light called photon. Just like this, and in front of my mobile phone and in my laptop, the screen are very, very bright. So meaning to say, there's a rays or particle of photon emitted towards my eyes, something like that. And the frequency is the reason why it is become bright and I receive the light. I can clearly see the things around me, something like that, okay? That's already a frequency. Okay, something, for example, red light, 670 nanometer wavelength. Okay, blue light, 480 nanometer wavelength. Okay, blue light, 425 nanometer wavelength. And the rest, chuba, chuba, chu, chu. White light, black light, blah, 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 purple. The Roy beef in a rainbow. You know? Roy beef in a rainbow. Red, orange, yellow, green, blue, indigo, okay, violet, something like that. Indigo, blue, and violet. Roy bead, something like that. Okay, that's the sequence of the color of a rainbow. Okay, so each color of a rainbow has its own frequency in terms of nanometer. Okay, all of those colors are only new three because I don't memorize the others. Okay, maybe if I encountered also in the future during my experiment during my reading and research, I could still also add some. Okay, but for now, I have three colors wavelength which is the blue, purple, and the red. Okay, something like that. Okay, at least. Okay, now going to this dual slit experiment. Oh my gosh. Di ba kaya ko kamao mo drawing, pasensya na lang jud kaayo ninyo in fairness. Okay, di ba namo ti murag bangag, di ba duha ka buok ana. Okay, mo drawing ko in fairness. Okay? So, understood na siya nga halo ha. Okay, dili halo, ganon. Ganon. And then there is a video light camera, something like that. Or a camera, something like here, somewhere here, na maproduce po siya o kanang kuan, rays, o ganon. And then, the electrons, for example, this is a particle, right? So, the electrons negative will pass through this hole. Tanawa ra good? Yung ani siya. Wow. Okay. So, ganon. Tanawa ra good ang drawing. Diba? Okay. There are two, actually ang slit hole raman po na siya in another term, but the slit is a small hole. Okay, slit, S-L-I-T. That is also a hole pot, a small hole. Because if we speak about hole, that's general. It could be big, small, average. But this slit really is small diameter or circumferential dimension. Okay, something like that. Okay, usually a hole also is circular, something like that. Okay, but there are also holes not circular. It depends, but usually hole are circular also, especially in this experiment, something like that. Okay, the electrons will pass here, and there's a camera with light ray also, and it will be bombarded to the electrons that will travel here horizontally. Okay, something like that. Now, there is, there's a screen here. Okay, like this. Mura siya satellite. Okay, satellite in the TV network or in a network provider in a internet, something like that. Just like a signal, something like that. And it will like this, like this, like this, like this. Awara good. Oh, ganon. Okay, and then it will produce like like an antenna, like circular shape, but like this. Ganon. Okay? Tanawa ra good. Mugana siya ba spiral. Bangga din dito siya sa interference pattern. Okay, kaya pag diffract sa light, na-diffract yun ang light ni higayuna. Okay? So, pag diffract sa light, ni bangga siya sa screen. Okay, this is the screen. This one. And then this is now an interference pattern. And after this, it will produce now a wavelength of this electron. So the wavelength will be now like this. Okay? Just like a spring, a notebook with spring, or just like an intestine of a chicken. Something like that. Or what else? Yung kanang pan na tuyok-tuyok bitaw mura kanang lami king pan na tamis na siya spiral na lami kayo, white ang color. Okay, nasa Cebu. Wow. So it's just like that. Okay? So we'll do like this. Ganon. just like a mountain. Ma-produce niya nga siya ang wavelength, guys. Okay? So, paakyat, pababa, just like a spiral. Okay? And this is also the pattern of the wave of the sea. Okay? The sea also produces wavelength each time during from low tide to high tide. Something like that. Wave. Okay? So, just like this. Okay? But in here only, light lang yun siya. Dili siya liquid. Not water or not sea. But the principle behind is just the same. Okay? So it will produce two siya because there are only two slits also. Okay. Now, develop siya mga ingana. Okay? And then, through that, ganon, curve siya, di ba? Na siya probability distribution. Okay, the probability distribution that will distinguish the uncertainty of the location of the electrons will it hit after the diffraction of the light ray, something like that. Okay, now it's gonna be like this. Now guys, just like a mountain, right? In here, technically this is called a peak, P-A-K, and this is the downside. We call this as a trough. T-R-O-U-G-H. When we sum up the trough and the peak, it will be equal to a one wavelength, so on and so forth. So if we have a multiple wavelength, meaning to say a lot of addition between the peak and trough, okay, respectively, at infinite level, especially the sea, because the sea surrounded the earth in Asia, in Europe, in America, meaning to say the wavelength of an ocean is infinite also. Okay, we cannot measure that directly in our naked eye, even though we have a device, because, you know, the surface of water in the world or in the planet Earth is very wide. Okay, as we can imagine for that. It's just also the same like this in electrons. So meaning to say, there's uncertainty already. We cannot measure by our visualization or by our sense of sight. So meaning to say, we will use probabilistic approach in determining the wavelength. Okay, that covers to this particular electrons. Okay, now here, so the downside, guys, will have a very low probability distribution, and in the top, in the peak, have a high probability distribution. Now, if we know to measure the amplitude, it's gonna be in the horizontal here and then in the peak. So that will be our amplitude. That was discovered by Mr. Max Born. He was not contented with the Schrödinger equation because the Schrödinger are only focusing to the wave functions, how it behaves. So even though the equation of Schrödinger are very comprehensive and, you know, it still have missing requirement. That's why Max Born, it's not enough. We need also determine the wavelength, the amplitude. Okay, this because when we say about probability distribution, amplitude must be very important. So they collaborate with each other, they correlate with each other. Okay, and Mr. Schrödinger accepted the theory of this Max Born. Okay, and then later, itungan na po si Kuan, katong gingon si Louis de Broglie. Iya yung computon ang wavelength of an electron specifically. Mo to nitungas na itong formula nga akong giingon ninyo. Okay? And then pag humani ana pod, nitunga pud kalit si Werner Heisenberg. Okay, dili na inap niya ibang kuan. I want to measure also a formula that to determine also the uncertainty of the location and the momentum. Okay, so nag-study na po pag-ayo si Werner. So there are all physicists in the past collaborating each other with each correlation with their scientific theories and factual science studies, something like that, okay? Particularly in physics. Something like that. So, ganun siya. Now, okay, duha man ni kabuok, no? Okay, so in order we can have the formula of Heisenberg Theory of Uncertainty, mathematical postulation. Postulate meaning ano? Theorem. Okay? Another term for theorem is a postulate. Okay? Gets? Copy? So when I say postulate or postulation, meaning a theory being discovered. Okay? Something like that. Okay, so like this. Now, magkuha na dyan ko sa aning duha ka wave. Okay? So ang wavelength, guys, from top peak to this first and for second, this is called the wavelength. Okay, here and here. Amplitude will be here, Here, ako lang drawing wala ako lang sa what, diba? Here will be the amplitude. Vertical distance lang yun siya ba, ang amplitude. Okay? Muna siya amplitude, ganon. And then ang wavelength, horizontal siya from one wave to another wave. Muna siya kitawag ang wavelength. Or else, it is not a wavelength kung usara yun siya. Lagi siya partner nga, asa siya mo, landfall. Landfall ba? Okay, mo end ba ang curve. Okay? Or else, hindi na siya wavelength kung wala siya pares. Okay? So, wavelength mo na siya. Here. Lambda man ang wavelength, guys. Ano siya? Okay? Ang kung na ato na siya tuyukon, ha? Kaya nagtakilid man ni. So, ano na ito? I-rotate na ito. Okay na na. Muna siya natabo. O karon, mag-drawing na ta. So, manamon naman to siya no. So, ato siya ibalhin diri sa another sheet of paper for further understanding. Now, we have here, mag-draw sa kuukuan, vertical nga. Nanako usa ka bangag. Okay. Consider lang naman ako usa kay duha man to ganina, di ba? For better understanding. One slit will be used only for further discussion. Okay, something like that. Okay, a very small slit here. Okay, and now the electrons will go there again. Okay, ganon. Ganon. Makalingaw man siya, eh. The electrons no, so diri-ari. Ganon. Okay, and now there is an interference as I told you, the screen, right? The screen, as I told you, muana din siya. Okay, mudro siya ng ani o. Usara siya akong gigamit ha. Okay, for the purpose of discussion, mo anak na yun siya. Okay? Now, here, ma-apply din ang trigonometry and algebra. Okay? So, we will draw an imaginary, not imaginary, the horizontal line. Okay? Like this. Ganon. Okay, purely imagination, right? Okay, wild imagination. Ganon. Tanawa. Okay, and now if we have like this class, we can create a triangle. Okay, okay, by drawing here, i-connect sa din mo siya dito sa kilid. Dito sa iyang katong tumoy ba sa wavelength. O, ganon. Kaloka. Okay, ganon. Okay, so na siya. Kung sa'y may tabon ining higayon na, okay, maka-create na kag angle. Okay, right triangle of Pythagoras theory. Diba? Okay? But before that, we will designate pa. So, unsa man ang atong delta D distance? Kay nagtakilid man ni siya, atong distance D mo ni siya diri dapita. Okay? Sa slit, guys, mubukaka ni siya. Kaloka. Mutaas, muubos, mutaas, muubos. Depende siya sa kanang kuan ba sa electrons nga imong gi-feed. Okay? Mutaas, kumubukakan ni siya, mugamay po diri imong kuan, imong kaning wavelength, mo closed siya ba? Ya kung mugamay po ni siya, mudako pud ang imong kani siya, kaning yang wavelength. Okay, kay dependent man siya kay mo man ni ang iyang gisudlan. Okay? Nakakuha na mo in fairness. Okay, ganon. Okay. Now, kay nag-draw man tag ingon ni Ana. Okay. So, nakakuha man tag mga angle-angle tsuva. Okay. So, we now create a big triangle for this. Okay. Mura na siya katong kuan katong reaction kinetics nga naay gamay, naay dako para makuha katag slope, slope nga gamay, slope nga dako. Pero ang purpose lang gyud niya ba para makakuha gyud tag slope. Ngani ra sad siya. But in here lang, wala din siya slope. Pero mora kaya pastorya ba? Big triangle, small triangle, and then equate, chuba, chuchu. Okay? And now we have here the big, let's say, P ni siya. Okay? Kaning vertical nga sa dako na screen. P. Okay? And then, we also designate the hypotenuse. You know hypotenuse? The incline. Kani siya ba? Mura ni babag na kuan, takilid. Okay, nga incline nga akong i-connect. Mo man siya hypotenuse. Okay, in our algebra kani siya hypotenuse. Okay, hypotenuse. Okay, base and opposite side. Okay, you get the point? Something like that. So, now we can have the angle, ano siya, theta. Okay, angle theta somewhere here. Kung kakreate naman yung kaani ining gayon na. Okay, like this. Sabihin ka, angle theta. Ganon. Here. Okay. And here also, angle phi. Okay. Ganon-ganon na yun. Unya kay, ato mong padakan ang P diri, padakan na purpose nga maka-create yung dako nga triangle. Okay, so ibukaka na to pag-ayo. So musaka sa ni siya atong triangle. Okay, so that's why atong balihin ng triangle here diri ha. Okay. Kabaw naman kita, we know that already that we can create a triangle, a right triangle. So atong i-separate na siya, in which mo ni siya. Okay, P. Okay. Kani siya dati pila man gyud siya tanan from here to here. Ato ra man ang segment by segment. Okay, i-cut na to siya segment by segment. So that is also P. Okay? Kakuha ka. For example, cake, imo siyang putol-putulon. Mahimo din na siyang ice cream. Okay, that's still a cake. Even though i-cut-cut na mo siya pila ka hiwa-hiwa. Masa na siya ang purpose diri. Pira gyud siya tanan ang vertical. You got the point? Okay, di na siya mausab. Kanang vertical distance. Okay, alangan man ang cake mahimong pan. Okay, so mo na siya diri. Ang pipira gyud na siya all throughout. Imo lang siyang giputol-putol. So for the purpose of discussion mo na siya analogy na nganong pilang gihapon ako gigamit. Okay, vertical man siya. Okay, so kana siya tanan from there to there, vertical man siya. Imo man segment to segment. Okay, so pilang gihapon na siya. Okay. And now here, the inclined hypotenuse will it thus as small letter P. Ganon. Okay, small letter P. You get the point? Now, since di ba ako siyang giputol, mapilang na siya, asa mang usa ka putol? Kani siya ba? Taas man siya nga P, long P, capital P. So the other one, half P, where is that? So we need to account that one. That's why this will become delta P. Change na siya sa P, yung imong i-account. So, kung gitudlo ninyo ba nga delta P because of final minus initial kay naputol naman siya, so nagyo na siya murag final, initial, ganon. So ma-delta P na ni siya. Okay? Kay katong tibuok P man to siya. You get the point? Mumunto ang total, kani kuha ra man ka sa difference mo ng delta P. Okay, nga P sad siya. Now guys, kani siya unsa may mong buhaton ni ini? Charot. Bisaya. Okay? So we have this triangle. Kani siya. Di ba magbutang kag theta, imo ra man gibalhin dito eh. So okay, mo ni siya. So imong buhaton ni ini, unsa imong gamit? What do we use for this in a Pythagoras theory? Opposite side over the hypotenuse, right? Okay, because there are given man. We don't have given in the base, or else cosine, we should use the cosine theta. So we need to use the sine theta, which is the opposite delta P over the hypotenuse letter P, small letter P. So it's gonna be like the sine theta, okay, is equals to the delta P over P. Then we can say also that delta P is equals to sine theta P. Kakuha ka. So muna naman yung equation 1. Kani. Equation 1 na nimo siya, okay? Delta P is equals to sine theta. Oh, now we go to the other parts in the here in which katong mubaka ka ang kuan ang dili sa gisudlan sa electrons. Mulit sa taglit vertical distance, parallelism man guys. If we have the distance there vertical, makuha sa vertical distance sa gamay nga kuan, triangle. Okay, so how can you get the smaller triangle here? So you can, construct another imaginary line from here to here, ganun. Okay, kaya makuha man mo. Okay, makuha na sa kama, project na sa kaglain. Okay, ang electrons makuha man gina siya pag-ayo, dagan ka siya no specific movement, going there, going there, going there, going there, going there. And then, luckily, ma-predict man sa mga scientists kay mo, triangle man dayon siya. Now, we have theory man in triangles, in right triangle, so ma-troubleshoot dayon nila ang posisyon. Okay? That's the point there. That's why experiment, okay? Like this. So, nagkuhan sa siya, okay, ganon. Okay, ganon. So ganyan, nag-project na sa tag another imaginary line going to there. Sa katong base sa kuan, sa wavelength. Diba? And then, ganon. So, makakreate na sa another small triangle here. Okay? Okay, gamay na siya nga triangle, guys. Okay? So, nagyapon kay angle theta here. Okay, between the vertical. Kay, this is, reverse naman siya, natuwad. So, meaning to say, the angle theta will be there in the vertical. Okay? Like this. Okay? And then we have the wavelength here, lambda. Okay? Wavelength is 1. Okay, di maklaro akong drawing, oy. Nakakaloka. Okay, basta na ang triangle, there's a wavelength here covers by small triangle. And then, muna siya natabo. And then there, we have also the mag-designate na tag letter, letter D. Okay, which is the distance, capital D. Or shall we say, X. Okay, muna na siya ang D. Na mo itong gitawag og delta X. So, kay dito man musud ang electrons originally, gitreat nato siya nga positioning first of the electron. And the final positioning we don't know yet. That's why here, D delta X. You get the point? Okay. Now this is D delta X. Okay. Ganon-ganon chuba-chuchu. Okay. Now, so ari na siya ni Mudri ko ano no. Okay, naman kay angle. So unsa man imong buhaton ni ining higayon na. Okay? So, kay imo man gituyok ang kaning delta X mahimo na siyang hypotenuse. Okay? Here. Okay? Okay, nagbabag mo ni siya nga triangle, wala siya parehaning usaba. Okay? So, we can say na sin theta na pud siya, sin theta is equals to the wavelength kani siya diri ari. Okay? Wavelength over the delta X, which is the D. So we can say also that lambda is equals to sin theta delta X. Okay? Delta X. Muna siya lambda. Okay? Muna itong equation 2. Okay? So lambda is equals to sin delta X. Now guys, kanina naka-equation 1 from the bigger triangle. And as like equation 2 for the smaller triangle, then equate the 2. Because it's just the same man siyang electrons dissolute sa slit, going to the slit and going to the screen. So you can say equation 1 is equal to equation 2. The law of equilibrium. Okay, in law of conservation of matter and law of conservation of energy in chemistry. Okay, as I told you, it's not limited only to chemical reaction, masses, it's also applicable in all types of correlation. The law of conservation of matter and law of conservation of energy, steady state flow in equilibrium. Okay, so sin 1, point 1 is equals to point 2. Triangle 1 is equals to triangle 2. Equation 1 is equals to equation 2. So, i-equate na to siya. So, delta P, ganon, sin theta, okay, ganon. So, in here guys, ang usa is delta E sin delta X. O, ganon. So, muna siya atong equation 1 and equation 2. Hala, then maglibog na yun ka. So, Sotero, how can we equate that one? There's no the same quantity. Okay? Maglibog ka. But be sure, guys, that there's a sin theta. The sin theta also in equation 1, nasa siya sin theta ang ikaduha. Right? So, compute for the sin theta. So, sin theta, okay, or we can see also directly as delta P, okay, delta P is to sin theta, ratio and proportion. Sin theta then equals to delta E wavelength is equals to sin theta delta X. Nawa guys. Ano siya naitabo karon? Wow, naitabo karon talaga. Okay, now, tanawa ang sin theta na they are in the denominator. So makancel imong sin theta. Right? So what we left is Criss-cross multiply in algebra, delta P times delta X is equals to the lambda, the de Broglie wavelength of the discovery of Mr. Louis de Broglie in 1927. Okay? Something to, we have now equation like this. Oh, kapit na makuha. Kaya ang Heisenberg, mauman ni siya. Delta P, delta X. Yan lang, lambda lagi na siya. But, the formula of lambda is equals to h over mc. You get the point? So we will substitute in the lambda. So this will now become delta P delta X is equals to h over momentum or m times c. Or like delta P delta X is equals to h times p. Okay, like this. Ganon. Muna niya siya, di ba? Kaya lambda man siya. Okay? Get the point? Now, so Sotero, the equation of Heisenberg is not like that. Remember, this is delta P, delta X greater or equal to h over 4 pi. Where is the 1 over 4 pi came from? You will ask me like that. Okay? So actually, guys, this 1 over P or 1 over MC is what the equal of 1 over 4 pi. Okay? And this said in the theory that this 1 over MC or 1 over P in here, okay, this is the 1 over 4 pi, and this is the factor of the errors that it will be attained during the computation. That's why it is greater and equal to naniguro gyud siya. Okay? Okay, again, I'll explain. As you can remember in chemistry and physics, a lot of formulas, di ba, equal diretso? You get the point? Okay. For example, if I have density is equals to mass over volume, did I say density is greater or equal to mass over volume? Di ba, dili? Because that is certain, that is gonna be really the formula. Because that is macro, studying in a macro state. This is micro, so there's uncertainty. So we could not say equal directly as delta P delta X is equal to h over MC or h over 4 pi. Okay, we cannot say like that. We will say delta P delta X greater or equal to h over 4 pi. Meaning to say, the value of this delta P and delta X will always be greater than the h over 4 pi in the other side. Now, if this h over 4 pi is greater, lesser, for this, it's okay. But if it is more than, problem. Because it will never hold to uncertainty principle. So there's something wrong with your equation. Or you solve the problem. Again, para masabtan. So delta P, delta X is greater. Nagikaon ha. Greater ka nang nagikaon man niya dito. Mumunita min halan sa greater than. O ya, kung iya ganing katong talinis mo ato gani dito sa pikas, okay, ang nasa ikaon, bukaka ba bukaka ang kanang triangle, less than na siya. Okay, it was taught in elementary level in education, greater than, less than. Di ba? Gamay pa kitang bata, gitudlo na maguna siya sa elementary, unsay greater than, unsay less than. Until college, it will still be coming out. Just like this. Okay? Okay, we are now, professionals, but still we consider this greater than, less than until now. Okay? So, dili na siya mawala. Nalagi siya permi nga mga symbol. Okay, delta P, delta X greater than or equal to h over 4 pi. And this is the formula of Heisenberg uncertainty principle. Okay? In short, this will violates the usual equation nga dito na siya equal. This is the exemption of all the formulas in science, in quantum mechanics, in the Heisenberg theory of uncertainty. Really, if we talk about uncertainties, meaning no specific, no exact, no definite, we cannot determine the exact, definite position and momentum of those particles because they are very, very small to consider. Okay? So that's why we need to have greater than or equal to, not really equal to. Okay, pwede masala ko dito na siya, delta P, delta X is equal to h over 4 pi. Why not? But why there's a greater than equal to? Because of this reasoning. This is very, very probabilistic in approach in the determination of the position of the electrons or the particles or the momentum also. So in short, in summary, in this particular topic in quantum mechanics, we are more on the experimental evidence through probabilistic approach of study, meaning probability. Okay, not deterministic approach. Because in chemistry and physics, they are all about deterministic approach, meaning macro. We can really see, we can really touch, we can really do whatever physical processes, and then it's very easy to determine. But here, this is probabilistic, just like probability and statistics in mathematics, right? We have a lot of sampling and survey before we can say, oh, this is gonna be like this. The population is very high, so the demand also is less. Oh, high, baron, nga na siya. Okay, the law of supply and demand, something like that in probability and statistics, right? And then if you toss a coin, tail and head, what will happen? Oh, this is probability and statistics. That's why probability and statistics is also difficult. Because you cannot really also determine the exact ano talaga siya, what will happen. Just like this, okay? In quantum mechanics. So our final formula will be now delta P, delta X is greater or equal to h over 4 pi. And h is the Planck constant. 6.626 times 10 to the negative 34 joules second. And the pi is 3.1416. Walang katapusang value of pi. Okay? Muna na siya. So, muna ang derivation. This is how we derive the Heisenberg uncertainty principle equation of Mr. Werner Heisenberg in 1947 after Mr. Louis de Broglie in 1927. All about quantum mechanics. Okay? You get the point? Something like that. Okay? Gamitin na natin siya per week eh. Makakuha naman po tayong mga problem. Ganun. Okay, so we will be able to show you to compute also values for the, how to compute the position of the electron, how to compute the momentum of the electron or any particle by using this concept. Okay? Get the point, guys? Like this. Okay, now we will be showing to you later in my next vlog. I will be showing to you problems on how to compute the particle position, uncertainty of position, and the particle uncertainty of the momentum. Okay, something like that. Thank you so much for watching this live stream. So I reached 47 minutes. Okay, thank you so much. And then you can comment down below in the comment section. And then you can also click for the notification bell for some news updates. So I am a senior agent of voice. And you can also subscribe my YT channel if you like. Okay, you have the full freedom if you like or not. It will be okay. Okay, thank you so much. Bye-bye everybody. God bless. See you later. Ganon. Hugaw naman ako drawing. In fairness. Kaloka.